Now we see Norrish type 1 reaction. Alpha cleavage of photoexcited carbonyl compound, so-called Norrish type 1 cleavage, leads to cleavage of carbon-carbon bond. This scheme gives simplified view of the possible pathways accessible by this reaction, starting from generic cyclic carbonyl compound X to explain the different products are observed. Irradiation of cyclobutanones, if N is equal to 1, generates a corresponding oxocarbene species via singlet 1,4 biradical in a reversible reaction. While this species is normally trapped by the solvent, bond cleavage to afford a ketene and an olefin, or decarbonylation, cyclization, or competing pathways in the absence of trapping agent. Now we see this mechanism if N is equal to 1. The first product is the formation of cyclization via decarbonylation. This is a 1,4 biradical due to the irradiation of cyclobutanone. Now it undergoes alpha cleavage giving 1,3 biradical via the decarbonylation. This 1,3 biradical recombine to give cyclopropene. Now we see how oxocarbene is forming. This 1,4 biradical undergoes cleavage at oxygen and carbon double bond, giving new radicals. Here, new carbon-oxygen bond is formed to give oxocarbene. Next, we see how we get this fragmented ketene and alkene. This 1,4 biradical undergoes beta cleavage, giving this fragmented biradical. This fragmented biradical recombined, giving alkene and ketene. For higher cycloalkenes, that is N is greater than 1, recombination of the intermediate cleavage product is possible, which leads epimerization or an intramolecular hydrogen abstraction may take place, generating aldehyde or ketene. Alternatively, decarbonylation cyclization is also possible. Now we see the mechanism of this Norrish type 1 if N is greater than 1. First one is the cyclized product. These 1,5 biradicals undergoes alpha cleavage, releasing CO gives 1,4 biradicals. These 1,4 biradicals recombine to give cyclobutane. Next, it undergoes intramolecular hydrogen abstraction. These radicals abstract hydrogen. We get again a new biradical. These biradicals recombine to give unsaturated aldehyde. The formation of ketene is also by intramolecular hydrogen abstraction. Here, this radical abstracts this hydrogen, releasing another new biradical. These biradicals recombine to give ketene. Now we see how the cyclized products are formed and oxocarbene, this fragmented ketene and olefin, and these unsaturated aldehydes and ketenes via the Norrish type 1 cleavage. Thank you.